All right. Okay, so since this is addition, we can rewrite the numbers. I'm going to do it a little differently this time. I'll rewrite the numbers. How come I can do this? Because it's addition, and addition is what we call commutative. Doesn't matter which order you add in. All right, so now I'm going to add these two values. 2 plus 3 is 5. And then let's see, can we add these fractions? Not yet. They don't have the same denominator. So we need to create a same denominator. Let's see, lowest common denominator is going to be 20. So multiply by 4, 8 over 20, plus, to make the 4 look like a 20, multiply by 5 and by 5. And we get 5 over 20. All right, so now they have the same denominator. Huzzah! So we can keep the denominator, which is 20, and add the numerators, which is 8 plus 5. It's going to be 13. And finally, we can write our answer as 5 and 13 over 20. Whew! That was starting to get to be a lot of work right there. Okay, that's it for 1.6. 1.7. All right, so this is, okay, so instead of adding, we are subtracting. So subtracting fractions must, once again, here is that little must. So I'll go ahead and furiously circle that for a little bit. Fractions must have the same denominator to be subtracted. Okay? So, let's check. Do these have the same denominator? Yes, they do, so we can subtract them. So we'll keep the denominator, which is a 3, and subtract across. 2 minus 1 is 1. All right, so, B, that doesn't actually have the same denominator, but we can do 2 over 1, remember? So, to make that have the same denominator, since it's a 1, we can just match it to the other denominator by multiplying by 6. So we get 12 over 6 minus 2 over 6. Aha, now they have the same denominators, so we can go ahead, keep the denominator, and subtract. 12 minus 2, 10. Oh, wait a second. Is that simplified? 10 and 6, those are both even numbers. I can divide them both by 2. That's going to be 5 over 3. So careful there, I almost boxed my answer, but that wasn't simplified. And remember, my direction said simplify if needed. Okay, so now I simplified it, and now I can box my answer. All right, so we might be tempted to do that breaking up technique we did with the addition, but it's a lot harder with subtraction. So because of that, I'm going to do a different method, and we're going to turn these into mixed numbers, into improper fractions. So that's going to be 9 times 3, which is 27, plus 1 is 28, minus 3 times 3 is 9, plus 2, 11. Okay, so this was a different method than I did with addition. Okay, please note that, because it's subtraction, I chose a different method. All right, so then subtracting that, that's going to be 28 minus 11, which should be 17 over 3. And that is not simplifiable. All right, not too bad so far. Okay, so subtract the following fractions by first creating a lowest common denominator. All right, so 3 and 8. What's a common denominator for 3 and 8? 24. Okay, so to make 3, let me just write this out a little bigger. So we're trying to give them both a denominator of 24. So multiply 3 by 8 to get 24. And then, using the building up property, I have to multiply the top. So that's going to be 2 times 8 is 16 on the top. 3 times 8, 24. Minus, all right, 1 over 8. How do we make that? Let's see, 8 times 3. And then got to multiply the top by 3. And I get 3 over 24. Okay, look at that. Now they have the same denominator. Huzzah! So, keep the denominator, 24, and then subtract the numerator. 16 minus 3, 13. And we are done. 13 is not divisible by any other number. Okay, go ahead and try B and C by yourself and check back with me. All right, B is similar to the other B. We're just going to put the 6 over 1, and then give them the same denominator of 4. So that's going to be 24 over 4 minus 2 over 4. Keep the denominator, which is 4, and subtract across. 24 minus 2 is 22. Are those both divisible by another number? Well, they're even numbers, so I know they're divisible by 2. All right, divisible by 2, so that's going to be 11 over 2. And 11 is prime. We're done. Lastly, okay, we got the mixed numbers, and this is subtraction, so we're not going to use the breaking up method. Since it's subtraction, we're going to turn these into improper fractions. So 4 times 3 is 12 plus 1, 13 over the original denominator of 4. Bring down the minus sign. Simplifying this, that's going to be 2 times 2, which is 4 plus 1. 4 plus 1 is 5 over 2. All right, can we make a common denominator? Well, if I multiply 2 by 2, I'll get 4. So let's go ahead and create the common denominator of 4. So it's going to be 13 over 4 minus 5 times 2 is 10 over 4. And aha, they have the same denominator, so we can go ahead, keep the denominator, and subtract across. 13 minus 10 is going to be 3. And that is simple. So we are done. All right, 1.8. Fractions, oh, interesting. Fractions do not need the same denominator in order to be multiplied. Okay, this is different. For addition and subtraction, they did need the same denominator. But for multiplication, they do not need the same in order to be multiplied. All right, things are changing. The times are moving. All right, steps. So for multiplying fractions, convert any mixed number or whole numbers into improper fractions. Multiply across the numerators, multiply across the denominators, and then reduce the product to its lowest terms. Sounds pretty straightforward. All right, so multiply the following. They don't have the same denominator. Do I need to create a common denominator to multiply? No. It does not matter that they don't have the same denominator. This is multiplication. So we're just going to multiply straight across. 1 times 15. Anything times 1 is itself. And then 5 times 4. 24. Can that be simplified? Let's see, 15 and 24. Those are both divisible by 5. Sorry, by 3. Wait, that's not 24. 5 times 4 is 20. Okay, those are both divisible by 5. Okay, we're going to simplify. Divide top and bottom by 5. 15 divided by 5 is 3. 20 divided by 5 is 4. And there we go. All right, B. Wait, that's not a fraction. But remember, we know how to deal with this. We had it as 3 over 1 times 1 over 9. All right. So let me just check something real quick. Yes. All right. So multiply across the top. That's going to be 3 times 1, which is 3. And then multiply across the denominator. 1 times 9, which is just going to be 9. Can we simplify those? Well, 3 and 9. Those are both divisible by 3. Okay. So our answer is going to be 1 over 3. The next one. Oh gosh, that's a lot, but we can do this, don't worry. So, multiplying across the top. It doesn't matter how many fractions you have. You just multiply across the top. Remember, doesn't matter how many. So that's going to be 2 times 5, which is 10, times 3, which is 30. And then, across the denominator, it's going to be 5 times 6, which is 30. Then 30 times 4. Oh gosh, what's 30 times 4? It's going to be 4 times 0, 4 times 3, 12, 120. Ooh, okay, so here's a trick. Trick time. See the 2 zeros there? That means they're both divisible by 10, so I can just go ahead and cancel out the zeros. And 3 divided by 12. Hey, those are both divisible by 3 again. So, our answer is going to be 1 over 4. Look at this. We're going to be multiplying these mixed numbers. Okay, so when we're multiplying, remember, what was the first step? Convert any mixed numbers. All right. So, let's go ahead and convert this. So that's going to be 1 times 7 plus 4 is going to be 11 times 2 times 5 is 10 plus 3, 13 over 5. All right, so now they are just regular old fractions. So let's go ahead and multiply across the top. I do not know what that is off the top of my head, so let's pull out the magical sticky notes and work this by hand. Because remember, chapter 1, got to do these things by hand. All right. So 1 times 3 is 3. 1 times 1 is 1. That was the first cycle. Let's do the next cycle, but first, remember, we got to add that 0. And then new cycle. 1 times 3 is 3. 1 times 1 is 1. We're done. So we'll add 3 plus 0 is 3. 3 plus 1 is 4. And then 143. Over 7 times 5, which is 35. Okay, and that is it. We are done. Okay, so first thing we had to do was turn those mixed numbers into improper fractions. All right, so here's something that might be helpful. We're going to practice reducing first, okay? So in mathematics, if you can reduce things, might as well reduce them. So to reduce terms, when you're multiplying fractions, divide both the numerator and denominator by the same number. So kind of what we've been doing before. You may reduce terms only if the numerator and denominator can be both evenly divided by that number. Okay, and when I'm talking about numerator and denominator, I'm talking about any numerator with any denominator. So I could cancel a number from 7 and 21, because that's a numerator and that's a denominator, as long as they're being multiplied. Okay, so let's go ahead and do that. 7 and 21 are both divisible by 7. I don't know why I wrote a 3. Let me white that out. So I notice the 7 and the 21 are divisible by 7. So rewriting this, that's going to be 16 over 21 divided by 7 is 3. Times 7 divided by 7 is 1 over 8. All right, let's see. 16 and 8, those are both divisible by 2. So I can divide, remember, as long as it's a numerator and a denominator, you can do this. And as long as it's a cross multiplication. It's going to be 8 over 3 times 1 over 4. Hey, 8 and 4 are also, again, still divisible by something. That means I didn't take out a big enough number. But it's okay. We'll go ahead and divide across by 2. That's going to be 4 over 3 times 1 over 2. Okay, so now they're all simplified. Okay, so real quick, please be careful. You can do this divisioning thing first, as long as it's a multiplication problem in the beginning. That's a requirement. And second, if you're taking something from the top and the bottom. Okay, you need to be dividing a numerator by the same number as you're dividing a denominator by. Okay, those are the 2 rules. All right, these are done. Oh, actually, wait, look. We can still divide 4 and 2 by something. My goodness, I should have just divided this all by 8 in the beginning. Oh, well. Just showing you can still slowly whittle away at a problem. Hey, and that's going to be 2 times 1, which is just going to be 2, and 3 times 1, which is just going to be 3. So my answer is 2/3. All right, and notice I lined up my equal signs and I boxed my answer. Alrighty. Part B. Let's see. First, before we do any of the multiplication, remember, got to get rid of any mixed numbers. So I see that mixed number there, so I'm going to get rid of that real quick and make that into 2 times 2 is 4 plus 1 is 5. All right, so now let's see. Because it's multiplication, I'm going to try to do that simplifying we've been doing. 2 and 8 are both divisible by 2. Okay, so now you might be tempted to say, hey, look, 4 is also divisible by 2. Please do not do that. That is a no-no. You can only be dividing by one numerator and one denominator. We cannot do it 3 ways like this. Okay? You need to divide the bottom by 2 and the top by 2. Cannot add a third party. All right, so once we've done that, let's see. That's going to be 5/1 times 4/15 times 45/4. Can we see anything else that could be divided? I see that 4 and a 4. 4 and 4, both divisible by 4. That's going to be 5/1 times 1/15 times 45/1. All right, can we simplify anything else? 5 and 15, those are both divisible by 5. Let's write this down again. 1/1 times 1/3 times 45/1. All right. Well, 1/1 is just going to be 1. So now let's see. Let's just go ahead and multiply across. 1 times 1 times 45 is just 45. 3 times 1 times 1 is 3. Okay, but that is an improper fraction. So I'm going to go ahead and do the division for this. 3 can go to 4 once. Oh, 3 can go to 15 5 times. Hey, 3 can divide 45 perfectly. That's 15. Wow, that problem actually ended up looking pretty nice. Okay, once again, notice the equal signs are lined up and I boxed my answer. Oh my goodness, is this the last page for chapter 1? I believe it is. All right. 1.9, dividing fractions. Okay, so we've done addition. We've done, subtraction. And we've done multiplication. So now we're doing the last one, dividing fractions. Aha, fractions do not need the same denominator in order to be divided. Do not. So the only time we need the same denominator for fractions is if we're doing addition and division. Sorry, I said that wrong. Addition and subtraction. Those are the only times. So need an LCD when adding or subtracting. So no need LCD when dividing or multiplying. Nice to know. All right, so for fractions, we have this thing, shorthanded way of saying it is called keep, change, flip. So the steps: keep the first fraction, change the division sign to multiplication, flip the second fraction, multiply across, and simplify if needed. All right, let's go ahead and do this. So here's a division problem. Wait, they don't have the same denominator. Do I need to create a same denominator? No, the answer is no, we do not need the same denominator. Do not spend time on that. All right, so keep the first fraction. Change the division to multiplication. And then flip the second fraction. All right, so now we've created a multiplication problem, which we know how to deal with. Can I simplify? Well, yeah, 6 and 2 are both divisible by 2. So we have 1 over 1 times 3 over 1, which is just going to be 3 over 1, which we know simplifies to 3. Awesome possum. All right, go ahead and see if you can try B by yourself and check back with me in a second. All right, 15 isn't a fraction, but have no fear, we know how to deal with 15. We just put it over 1. Divide by 5 over 6. All right, we don't like division. Let's turn it to multiplication. So it's going to be keep the first fraction, change the sign, and flip the second fraction. Can we simplify? Yeah, 5 and 15. They're both divisible by 5. So that's going to be 3 over 1 times 6 over 1. Multiplying across, that's going to be 18. Multiplying across the bottom is going to be 1. But we don't need to write that 1. We know that 18 over 1 is the same as 18. We're just going to keep that as 18. Once again, notice the lining up of the simplifying and boxing my answers. Ooh, snazzy. So we have mixed numbers and division. Okay, so the only time that we don't turn the mixed number into an improper fraction is with addition. For everyone else, we're going to work with the improper version. So let's change that to improper. It's going to be 6 plus 1, 7 for 2. Divided by 4 times 1 is 4, plus 1 is 5. All right, so we have a division of 2 fractions. Let's go ahead, do the keep, change, flip. Flip. Can we simplify? Yeah, the 4 and 2. Divide by 2, divide by 2. We're left with 7 over 1 times 2 over 5, which is going to be multiplying across 14. Multiplying across the bottom over 5. Okay, so you could turn this into an you could turn this back into a mixed number if you wanted to. Let's go ahead and just do that for fun. So 14 over 5 is improper. So this could be a good answer, depending on how they want you to answer. Or how do we turn that into a mixed number? We'll do the division. 5 can go into 14 2 times. Do the subtraction. So our answer is going to be 2 and 4 fifths. There we go. Either answer is acceptable since I did not state how you need to answer. All right, last problem for chapter 1. Huzzah, huzzah. Okay, we're going to ask to simplify this. So that looks really intense. What is this? Well, it's just the division of 2 fractions. We have 4 fifths being divided by 3/8. This is just another way of writing 4 fifths divided by 3/8, which we know how to deal with. Okay? Means the same thing. Okay, so we already know how to deal with that, so let's go ahead and do the keep, change, flip. Keep, change, flip. Let's see, can we simplify any of these? 4 and 8. But darn, you need to have it across from a numerator to the denominator. So we can't simplify the 4 and 8. So those are going to be multiplied. 4 times 8 is 32. And 5 times 3 is 15. Alrighty, and that is simple. And that is it for chapter 1. Awesome, we have made it through.